My name is Chris Chapman. I'm a senior methodologist at Spirent Communications. And today, what I will be showing is one of our tools for doing large-scale emulation for both attacks, applications, and protocols. Okay, so this is an introduction to Spirent CyberFlood. That's the name of our product. And here's basically what the functions of CyberFlood provides. So it provides a single solution for all stages of testing. So from functional to system to scale, testing, you have a single web and API-based way of actually testing that. We break security testing up into discrete manageable steps. This reinforces CI/CD policies and continuous testing best practices. We solve the problem with attacks and applications. Of course, especially with attacks, time is everything. In terms of how do you actually get these attacks into a ready-to-test state? So one of the challenges that a lot of testers test in cybersecurity is the fact that it's difficult to find attacks, to obfuscate those attacks, and to make sure that they're actually current, right? For example, an 8-year-old attack probably doesn't help users, in modern testing, right? So you want your 0-day attack, you want your most current DDoS, your most binary attack, to be able to test that scenario, right? So what we do is we push this content to you every 15 minutes. So we provide test updates and updated methodologies that represent real world scenarios so that you're in a always ready to test scenario. We allow you to blend high rate attacks and validate service generation, at modern gigabit rates. So it's possible to generate, from as small as, let's say, 1 gigabit per second to hundreds of gigabit per second, even in our virtual and cloud interfaces. We provide an emulation platform for allowing you to test security as a service and do fault isolation, such as detections, right? And then, of course, we offer this in both physical, virtual, data center, and cloud environments. We do provide a web-based GUI, but we're fully comfortable in a REST Python environment as well. So if you look at the test topology in terms of how you set this up, we actually begin with the device or network that you test. This is actually important because this allows you to isolate what you're testing and basically put a box around it. Surrounding this, you can have test endpoints, and they, like I said, they can be physical, but in the virtual data center space, we support QCOW2, so KVM, we support ESX, and we support cloud in instances such as AWS, Azure, GCP, etc. So you can have as many of these virtual endpoints as you would like. You can deploy them on the fly, right? And then you can use that to generate both application, protocol, and attack traffic through the device up to hundreds of gigabits and be able to do deep inspection and KPIs. Controlling this, you have a virtual controller, which is in itself a VM. And this kind of has 3 legs. One is control of these inputs, right? Another is the web or REST API interfaces, which, and of course we have admin and user level accounts. And the third is the continuous push of content, application and network threads, which is pushed every 15 minutes to the controller. You basically access this through a modern web UI. In terms of deployment in the field, we deploy these in blocks of 4 vCores. So you can have up, kind of like an extra small to an extra large type of effect, up to 16 cores per endpoint. And like I said, you're not limited by the number of endpoints. And we do support DPDK, SRIV, PCI bypass, and direct path IO, accordingly. We also support this expansion in cloud modules, such as, AWS C5 and C9 type of modules. Yeah, and finally, like I said, everything is REST drivable, right? So this is pretty agnostic, in terms of being able to control. And in fact, the UI that I'm going to show you now actually has a built-in REST generator so that you can actually test things out. So here I have the CyberFlood Web Demo, and I'll go ahead and use that just to convey concepts here. So what you see is a dashboard that basically shows you what's actually going on. So here you see how much content. So right now we have 21,156 applications and almost 80,000 attacks in the database that we're currently on, which means in every 15 minutes, this is being updated with new content as it hits our database. This gives me some basic what's happening on the controller. I should mention that the test does not actually reside on your PC, obviously. It resides actually and runs on the controller, so you can disconnect, reconnect to a live test. We implement the concept of a queue. And what a queue is basically it allows you to take test ports and group them together. So when you go to form a test, you select a queue which has test ports in it. What's nice about this is that you can stack tests one after the other using that queue, or you can interleave users or other processes stacking within that queue. So it really reinforces interleaving and being able to reuse your resources. I can create project workspaces, and inside those workspaces, I can actually have, different groups of users contributing to tests. And then down here, I actually have a library of results here. So if I expand this, you can see I have these graded cards, and they actually represent, different test runs within that test interface. So what CyberFlood does is it, like I said, it breaks testing up into logical, manageable chunks, right? So, so if you go over here to the test builder, you can basically create performance tests, capacity tests, security tests, and advanced mixed traffic tests. So if I come down here and do, for example, a throughput with mixed application, this would be an emix test. Now, one of the things that makes CyberFlood unique is the fact that we're not just doing block transfers over TCP, such as a tool like iPerf does. That tool has its place, but it also has its limits. And part of that limit is the fact that real TCP in itself doesn't actually drive anything. It's completely dependent upon what's bound to the socket, right? So if I have a protocol like HTTP driving TCP, it's going to drive TCP differently than, let's say, FTP, right? Or TLS is going to drive that different, than FTP. And even there's a dependency too, because the HTTPS stack in itself does not actually do anything. It's dependent upon the orchestration at the application level. So what we do is we take realism way up to the very top of the stack, even beyond layer 7, where we're actually emulating the user actions over time. We call those SIM users, and they represent you sitting in front of a terminal or a device, going through actions, walking through a site. So I'll give you an example. Let's say I want to log into YouTube, spin up a video, watch it for so much amount of time, go to another video, maybe post a comment, and then log out. We actually emulate all of that behavior, and that can be done either over TLS or clear. Why is that important? Well, if you think about it, layer 5 is just the beginning of realism, right? So if we take, like I said, a tool like iPerf, it kind of stops at layer 4. So we're emulating layer 5, layer 6, and layer 7, right? So we're dynamically, generating all of the traffic, but we're also emulating the user behavior, making decisions about, which page do I go to, which content do I stream, and the key thing here is that there's nothing above the user, right? So if the user has a good quality of experience, by definition, you have your penultimate metric for actually measuring actually any network, be it stateful or stateless, right? Because then you could start to answer questions like, given my specific mix of applications, right? How many users can I get across the network before quality of experience comes down? That's a much better metric than bandwidth. Bandwidth doesn't have a lot of meaning when you're talking about quality of experience, right? You have to directly measure and generate quality of experience. Likewise, if the device under test is causing a fault, or an impairment, like dropping a packet, right? There's consequences that have to be paid back for TCP-based applications. So what this means is that we will play back those consequences just like a real TCP stack on a real client, except what we do is reproducible, highly scalable to thousands, millions of users, gigabits of traffic, right? So it's like taking the entire internet and doing file save. right? And being able to load that whole capacity and be able to replay it back exactly. That's critical when you're trying to, let's say, debug, right? Or prove that a patch is actually working, right? And conversely, it's impossible to do when you're trying to orchestrate thousands of VMs at a time. It's just, you get into timing and synchronization problems. So in this particular module, throughput with mixed applications, we're able to actually set up that emix of traffic. Now, again, I can mix both protocol and application traffic down here. So what am I going to do? Well, I'm first going to pick a queue here, and I can pick the pattern. Do I want the users to do pair or backbone, which basically means, do I want them to interleave or round robin through servers? And then I can come over here and define my subnets. Well, I can also filter. So what you see over here is the palette, and this is actually a big advantage. As more and more users are contributing, to the system, then what you can do is basically reuse other parts. So we have this idea of breaking tests into profiles and allowing you to reuse those profiles, like an application mix, for example. So here, what I'm going to do is I'm going to come down here and I'm going to pick a subnet that I've already created, and I'm going to simply map it to a port. Right, so that's my client. I'm going to do the same thing with my server. Notice we give you validation checking as well here. Now, if I wanted to go in and modify this, I mean, I can have up to 25 actual subnets in play, and they could be IPv6, IPv4, mixed VLANs. It really doesn't matter. I can say diff serve code points. I can add VLANs here, but you'll notice here that I can pick a static range. I can use DHCP, or if I wanted to, I could even use geolocation caching, right? So some firewalls, for example, might block traffic from the United States, for example, or Canada. So what I can do is I can say how many total IPs, and I can give it percentages. We'll go out, grab the IANA blocks that are current, and then apply this percentage to that too. So it's a very useful way of, and helps you kind of move forward with your testing that's much more realistic. Okay, so I'm going to go ahead and do this, right? If I want, I can also tune the TCP stack parameters here. Right? So I can change any of these. So again, we do use real TCP. It's full state. And if I come over here, right, this is actually going to be my mix of traffic, right? So if I go to an individual protocol, and let's say I just wanted some basic HTTPS traffic, what I could do is I could go ahead and edit this. And let's say I wanted to maybe, I don't know, I wanted to remove some HTTP 1.0 traffic, right? And maybe I wanted to come over here and edit my HTTPS settings. Well, we also implement full stack HTTPS and TLS, SSL, the whole thing. So these are your basic TCP parameters, right, that you can modify here. But if I come over here to supplemental settings, I can actually control whether I want TLS 1.2, 1.3, or SSL. I can control what ciphers I'm going to statefully negotiate and rekey. I can configure groups. I can upload certificates. I can change the rekey size. So again, fully stateful, right? And again, if I wanted to like change a percentage, it's just a simple matter of dragging and dropping and changing the percentage here. So I'll go ahead and exit this, right? Likewise, if I wanted to, I could come in here and I could add attacks or malware, right? So this is your needle in the haystack type of attack. In this module with this methodology, you have a lot of valid traffic, and then you have a little bit of attacks to see whether or not your firewall will actually detect that, right? So in a kind of a red card, green card, blue card type of effect. So if I wanted to look at a specific attack, like here's happens to be an Oracle attack, right? I get a description and I get a background of the traffic. Now, this is really critical. I have visualization on all of my workflows, be it application or attack. So I know exactly what is going to happen with this attack here. So if this is something that's acceptable, right, then what I can do is I can go ahead and add this to my profile. Here's another thing, this import scenario. When I do this, let's say that I have a proprietary attack or a proprietary workflow. It's in the form of a PCAP, and I want to reconstruct that. Now, notice I'm not saying play it back. I'm saying reconstruct. So we can do that. We can import PCAPs and reconstruct it. So what does that actually mean? Well, what it means is that we will go and we will break the client and the server into the appropriate sides, right, and allow you to map them to unique test ports. So if you wanted to play that back across an SD-WAN over a topology, there's no problem. We will strip away the original L1, L2, and L3 and L4 headers, right? And then we'll reinsert them into L4 headers and then assign them to the SIM users inherited metrics like their MAC address, IP address, VLAN. So I could take an attack, for example, that maybe originally was an IPv4, and I could replay that as an IPv6 with VLANs, to give you an example here. So this is very powerful because you can do import attacks, you can import traffic and add to the local repository, the data store here. Okay, so let me go ahead and cancel this here. All right. And what I'm going to do here is I can now come over here and I can define pass-fail criteria here, right, which is actually very important here. And I have some runtime options as well. So maybe I'll do this. Okay. So, and I can, and then I can determine the load of this test. So this is time. This y-axis represents what's called the specification. So it could be bandwidth, concurrent SIM users per second. It's kind of up to you, really. I can also turn on constraints. So if I wanted to constrain this, I could here. So I can make a change by just dragging and dropping, whatever I want. And then I can change my total duration. Now, soak testing is a very important concept, especially for application traffic. So notice that we can go up to 72 hours of test in a single test and as short as 6 minutes and 30 seconds per test. So what I'm going to do is I'm going to go ahead and start and run a test. Now, like I said, I'm using a GUI right now to actually drive this test, but I could have done the entire process of creating objects, assigning objects to profiles, applying profiles to test players. I could do that completely through REST if I wanted to. So if you wanted something that was completely automatic, then you could do that through REST and inherently drive it through Python as well. So what we're doing here is we're building the test, we're downloading the content, we're compiling the content here, and then we're uploading that to the test interfaces. Now, I will mention too that you can have complex topologies. You don't have to do an east-west test port scenario. You can have 5 endpoints sitting at maybe an SD-WAN mesh, right? And you could have us, you could go through automation, go deploy our endpoint, and then set up the test, run it, and then mesh across 5 different endpoints, grab the metrics, and then tear everything down through API here. So this is our live test. And what this is doing is it's giving you some visual and table views. So if I look at like the runtime statistics, I'll be able to see how many TCP samples, Ethernet statistics, TLS statistics. I can obviously see things like charts here. So I'm starting to generate some traffic. I can see some other KPIs like bandwidth, metrics, mix. Now, this is actually really kind of important because this is starting to get down to the application and protocol usability and metrics. So, for example, here you can see I can see both incoming and outgoing by protocol and or application here. This is actually important because you don't need to load up a PCAP post test and figure out which packets belong to the Exchange flow versus which packets belong to YouTube. We kind of do that for you automatically. In terms of latency, we'll give you histograms that'll tell you percentiles, by URL. So this will tell me how much time in milliseconds, versus a percentile you were in. So this is effectively a latency chart here. And then down here, we give you an even more inclusive chart by showing you all the protocols and applications. And then we actually give you metrics. So we're actually doing per application, QoE metrics in real time here. Now, the nice thing about this is when this is going, I can go off and configure another test. So I don't have to stay on this test per se here. Now, let me talk a little bit about analysis, because that's actually a very important topic. And this is one of the ways we think that we can help you. So we look at results as a pyramid. So the very top of the pyramid is some kind of score or grade. So you'll see a bandwidth score, a sim user score, a grade like an A, B, C, D based on a policy, right? The next level down is basically your basic tables and charts. So this gives you overall metrics of the tests, so test summaries. The next level down from that is we're going to break that down into real time. So we'll take all of these events, put them on timelines, and then show you how things were modifying and changing over time, right? And then the last level, of course, is even more statistics down to and including PCAP captures of what we generate and what we receive. So this test is running. So what I'm going to do is I'm going to come over here and I will kind of talk about these sections and then I'll focus on the cybersecurity section, right? So if you look at testing, this is kind of the recommended order of actually doing testing. You begin with your individual protocols here, right? Then you work your way up to capacities tests, right? Which look a lot like this, except they're isolated to specific protocols. And finally, you go down and you check the security. Now we break security up into these modules. So we have an advanced mutating fuzzer, or we call it a smart mutation fuzzing. And what this will basically do is this will test the hardness of your protocol stacks. And we've got tons and tons of protocols already in the system. What this basically allows me to do is come over here and I can pick a stack that I wish to test. So let's say I want to pick maybe a DHCP v4 service, right? Or let's say TCP, that's even better. So what I can do is our fuzzer is both smart and mutatable. So what that means is it understands the finite state machine of the protocol that you're testing, and it's going to be able to walk through it appropriately. I like to use it as an example. Before I send a BGP update, I actually have to form my BGP peer, right? So we're going to walk through the state machine we're in full regression, right? And we're going to go to every single branch in that state machine, and then we're going to take every field and mutate that field. So we're literally creating thousands and millions. In fact, we did a quick calculation for HTTP. There were over 14 million combinations that we tested, and we're going to, try to break the stack, right, effectively by sending mutated, intentionally bad, combinations. Now, when we detect a problem, and the way that we detect it is actually through restarters and monitors, right? The monitor can go in and basically you define what good means. So is the stack up? So I can call code. I can basically SSH into the device and look for a string. I can call an SNMP trap, whatever you might need, right? And in fact, I'll go ahead and show you what monitor types we have here, right? And basically you're defining, is the target up or down, right? So what we do is we will do a block of attacks and then test. If that stack is still up, we move on to the next block and we keep doing that recursively. So one of the nice things about this module is it's completely hands-off. If we detect that there's a problem, and let's say that there's a fault in the stack, which you as the programmer decide, right? Then what we do is we go back and we retest it. So we want to see whether or not that device is actually in a reproducible state or not, because it gives you kind of different debugging paths if it is or is not. Now, if for some reason that stack is not available, we're going to issue a restarter. And what a restarter does is it basically gets the device under test or network under test back into a known good state. It may be as drastic as rebooting the device. It may be as more fine-tuned as just killing the process and restarting it. You as a programmer can decide that. So we've got a whole bunch of APIs, including virtual APIs here. So what we do is we go through and we tag this, and we will actually show you what specific patterns at what specific location was actually causing the device to crash or have a problem. So if you think about this from a cybersecurity perspective, one of the ways that attackers actually try to find vulnerabilities in a device is they'll look at the individual stacks and see whether or not they're hardened, and they'll try to find entry points by maybe killing the stack and working around the stack. So this module allows you to do future testing as well as current testing, right? Because you can automatically and recursively step through every single permutation of packet branch in the state machine and so forth. Now, and of course, we'll show you visually, like what failed. We'll give you PCAPs, give you a lot of information. Now, if I turn this on, each fault is assigned an iteration number. So I can type in these iterations with a comma separated list. And instead of going back from the beginning, you can just retest, in a pinpoint fashion, what specifically failed. You can also cap this whole thing off at a maximum amount of time as well. So this is a good place to start with cybersecurity, is making sure each and every protocol stack is hardened. Then what you're going to do is you're going to come down here and do DDoS testing. So what this allows you to do is test the two different types of DDoS. So you have stateless and you have stateful, right? So the big thing with DDoS is DDoS in itself at low rates is not so interesting. It's what happens when you get into the gigabit rates, right? Where maybe an attack hijacks, let's say, a whole class of mobile devices, and then at a predetermined time, they all try to attack a known interface at the target, right? So we can generate gigabits and gigabits of volumetric DDoS here. So if I want, I can come over here and edit how much DDoS, I want to actually configure, and I can do that here. So I can see what kind and the type. And then of course, we're going to backfill this, which is going to be here. We're going to backfill this with HTTP, because one of the other attributes of testing is you want to make sure that the mitigation process of handling DDoS doesn't affect your valid traffic. So this is a way of actually checking that. So this is the volumetric DDoS. If I come down here and do protocol DDoS, it's very similar, except that, what's changed is we're doing protocol-oriented DDoS. So here I can do connection-oriented, SYN, REST, Xmas tree type of attacks. So once you get past your DDoS testing, then what you want to do is you want to come over here and you want to run the cybersecurity assessment. And I like to say that this is the one that in a CI/CD model, you're going to run based on change, right? So if there's a change, let's say new code, new policy, new VM instance, whatever, in your chain, this should kick off a CSA attack. Let's see if I might even have one over here. Actually, yeah. So what the CSA attack does is it basically is for your firewalls, IPS, IDS style device. Let's go ahead and continue to wait here. And what I can do is I can define a set of attacks that should be identified, but basically not blocked, right? And then I can control actually, let me do this. Let me exit this. And let me go back. Let me log back in. And and then you can define what attacks are actually should be blocked, right? So, and you can mix them together. You can also mix them with valid traffic. So what you can do is you can say this block should be blocked. And so if it's not blocked when I'm running my test, we'll actually tell you what the, that it wasn't blocked. And then also we'll show you in the ladder diagram, at what point, for the ones that were blocked, how far did the attack actually get in before it was actually blocked, right? So like I said, this is something that's probably most likely going to be used through automation, right? And a part of your CI/CD process as well. And then finally, the last module is our mixed throughput test. And what this module allows you to do is this allows you to set up custom tests. So this is not necessarily oriented towards a fixed methodology. This basically allows you to set up, any kind of test. So again, you always start by picking a queue. here, right? And let's say I wanted to pick, a subnet here. I could do this over here, and then I could do this on the server side. Notice I don't have to save the profiles if I didn't want to here. And I could make this a different subnet there. Or I could, again, just come over here to my subnets, pick this over here, right? Then I could assign this to a port. And then I could do things like I could start picking, network, parameters. So this is going to allow me to, control my configurations. And then what I can do is I can drop this over and I can start editing, these particular mixes. So now I can go in and I can configure individual elements here. This is what we actually call smart apps. So what this allows you to do is go in and say, well, instead of defining, predefined, order of events, from the library, I want to kind of have an API for Facebook or an API for Instagram. And in this particular case, I'm logging in and logging out. I could have actions that are like maybe transfer a file, stream a video, and so forth. So like I said, this just allows me to configure whatever I want, kind of independent of a predefined methodology. Now, the last thing I wanted to kind of focus on is the REST API. So we have the full API is published, right from the actual controller itself here. So here, I can, here's examples of a Postman collection that I can download. I can see like what my key and type is here. I see examples here, right? And, I can come over and go to a specific function. And I could look at the filter for that particular function to see exactly what's actually going on here. Right. So like I said, we definitely have full API support, and it's like I said, it's how most people actually drive this in a CI/CD type of platform. Okay, so with that, let me just ask to see if there's any questions.
Yeah, one question, Chris. I think this is amazing. First of all, let me start with this. This is an amazing demo for our community to look at it. I think one question that I'm sure all of us wants to know, how to set this up. Let's say I'm on the ground zero and I have contacted Spirent for CyberFlood product.
Yeah.
What would it take for me to get to the screens that you have shown today?
Absolutely. Yeah. So where you start is you start with the controller. So based on your hypervisor platform, let's say it's ESX, you or we would probably end up working with you, to actually do it. But you would basically download the OVA for the controller, and you go deploy it like standard. So it's already pre-encapsulated into the appropriate container format. Right. When you actually go log in, you would just web into the interface from the hypervisor shell. And it's basically going to run through a wizard that's going to allow you to set the management IP, and then eventually ask for the license. So the license is based on the UUID that's generated in real time. And you basically send us the license, we send you the file. You basically just upload the license. The license actually just resides on the controller. So once you install it, you don't have to worry about it anymore. And then it's going to ask you to set up like the admin account, and then finally any user accounts. When you do that, then the next step is you would just log into the controller, as your admin, and there you can verify that you have network connectivity. We'll show you a green light, red light, whether or not it can reach Spirent to start downloading the content. From there, you would just go deploy our virtual endpoints. So again, they're also given to you as OVAs, QCOW2s, AIM endpoints, and you would just deploy them like you would any other VM. There's one small step where you just shell into the endpoint, configure the management interface, and then when you're done, then all you would do is come up here to the device manager, and you would register that endpoint. And you can have as many of these as you want. So I could just add a device here, and here you can actually see we've added a VM, and and then once it's there, then finally you just create a queue where you allocate those ports into reservable units, and then you're kind of in a ready to test state. I will mention that the initial download of content, if you do it from like not having anything, can take up to 48 hours because it's a big database. If you wanted to speed that up, we have an offline version, which is a 1 month old version, and then we'll just do differential syncs until you get up to that point. And then you're kind of in a ready to test state. Did that answer your question?
It does. And what about the cloud testing? If I'm using AWS or Azure or GCP, how would that be added here as well for testing?
So really exactly the same way. All you would do is just deploy the cloud endpoints, into your VPC, and you can just drive them. Now, keep in mind that I can have tests that go across clouds or across data center platforms. This is very, very useful when you're doing things like ESX on AWS, right? So I could have instances installed in ESX, I could have it installed in AWS, and I can transit, I can build traffic that transits, cloud to data center.
Got it. Perfect.
Yeah. Yeah. So here you can see all of the different types of apps. I mean, we have a very, very big database, and like I said, like here's Messenger, for example, right? I want to show you this because I think this is a good example of the smart app. So I mean, obviously, Messenger is a very popular messaging program, right? So if I edit this smart app, this is actually really kind of nice because this smart app builder basically allows me to use APIs in a user-friendly way that are meaningful to that particular application. So, these are basically, my different streams. Within each stream, I can say, oh, log into Messenger, go to the homepage. I want to do an inline chat. I want to do a file upload, and then I want to log out, right? And then if I want to edit the attributes of that action, right, I can control it here. So if I wanted to take a real file and upload it, inside of an emulated application session of a Messenger session, I can do it, right? And like I said, I can now scale this up to millions of users, gigabits of traffic, and I have full reproducibility.
When zero-day vulnerabilities comes up, at that point, they're not zero anymore. Can we use your product to test? Let's say if we had a SolarWinds vulnerability. Now, if I don't have SolarWinds in development or somewhere that I can deploy it quickly, can I use your product to test and make sure that what would be my attack surface?
Absolutely. And all we need, if it's not already in our database, all we need is a PCAP of what you want to regenerate and recreate. And I can take that attack, import it, into the system. It remains local to my environment. So I'm not sharing that with Spirent, right? And then I could, scale that into my test.
I think this is very good first session. Next session, we will focus on how to create a demo from ground up. We will try to do it on our lab. We'll record it and we'll show it our community how you can use CyberFlood to actually test.
Definitely. Great. Well, thank you, Victor, and thank you, everybody.
Thank you, Chris.
Have a good day. Bye.